Okay, so we want to do an example of find the equation of a plane through 3 points. And this one happens to be 14 and 13.4. So they give us 3 points that are the standard, like I, J, K, M's, right? Okay, so what do I need to find to get a plane?
Was it general form of the equation?
Yeah, general form.
Okay, so I got to remember one or the other of the equations of a plane. Which one do you guys want to do? Do you want to do the function one, or do you want to do the normal vector one?
I just know them by like what they say.
X minus X.
So one of these is n dotted with some displacement vector is 0. And that's the one I'd recommend in general for this. You could muddle this one through with the other equation, but other examples are going to be way harder. So what I would advise is that you just kind of throw some stuff at the board for a second, right? So I'm just going to write down these 3 points, and I'm just going to pretend that they're dots in kind of random spots. Cool? Like I'm going to pretend that the board is the plane I'm looking for, right? Okay, so I got 1, 0, 0 here. I got 0, 1, 0 here, and I got 0, 0, 1 here. And those don't really have to make any sense. Okay? Now, to use the normal vector equation, I need to find a vector that's perpendicular to this thing, right? That's going to be your starting point. Okay, so I have a tool that takes 2 vectors and makes one that's perpendicular, right? Cross product, right? So how do I find 2 vectors out of 3 points?
Displacement vectors between any of the 2.
Yeah, pick a pair, doesn't really matter which, and make the displacement vectors between those. So here I picked this point, 0, 1, 0 as my base for some reason. It totally doesn't matter what point you pick. Okay, whatever. Then make 2 displacement vectors. So what's the displacement vector between 0, 1, 0 and 0, 0, 1? 0, 1, 1. You guys buying that?
Negative 1, 1.
So to get from here to there, right, I had to go nothing in the x. I had to decrease the y by 1 and increase the z by 1. Or you can do this by take the terminal point, subtract the initial point. Cool? So here I got a vector 0, negative 1, 1. How about this guy? 1, negative 1, 0. Good. Cool. All right, so there's my 2 vectors, right? I want a vector that sticks straight out of this surface, right? So I should cross product those 2, right? Do I care whether the normal vector sticks out this way or that way?
No.
Nah. So pick an order and cross product them. So this is why you might need that formula instead of that geometry thing. Because I don't really want to try to figure out the angle between these 2 things and yada yada blah blah, right? It'd be easier to just freaking calculate.
So a vector that sticks right out of the terminal point 0, 1, 0.
Yeah, and I'll base it at that terminal point 0, 1, 0 in the end here. But right now I have 2 vectors, I just want to calculate their cross product.
Okay, so would the angle be pi?
So I drew it like it was pi over 2, but it probably isn't quite.
It should be like a 60, 60.
Yeah, it should be 60 degrees,
Okay.
I think. But for the general purpose, just throw them in the cross product formula.
Alright.
All right, so if I throw them in, and it doesn't matter which order, right?
1, negative 1, 0 first.
So I got 1, negative 1, 0, and 0, negative 1, 1. I'm going to say, okay, so this is I times
Negative 1, 0, negative 1, 1.
negative 1, 0, negative 1, 1, minus j times
1, 0, 0, 1.
1, 0, 0, 1. I'm liking these zeros, right? Those are going to make my life easier. and k times
1, -1, 0, -1.
1, -1, 0, -1. Cool. So your result out of this vector should be what? What's your first coordinate? -1 minus -0 is -1. Out of this guy,
Minus 1.
1.
you get 1 out of the little matrix, right?
Yeah.
And then you need to remember the minus sign.
Oh yeah.
So 0 minus 1 minus 1.
So this would be 1 minus 0
Times.
times -1.
-1
Cool.
Yeah,
minus
I
0, so -1 again.
And this guy will give you -1 minus minus -0.
Plus 0.
Let's go with -1 on that one.
Yeah.
Okay, so I found out that the vector that sticks straight out of this is this guy.
Okay.
So how do I write down my equation of a plane?
-I minus j minus
Would be 0 equals x plus y. Or 0 equals x plus y. Because you can multiply that by
Okay, so I could flip the signs on this, right? And that won't change anything.
right.
That's a good thought.
Can you pick a point on the plane with x minus x1?
Yeah, okay, so I need another point on my plane here. I'm going to call that point
Our middle one should just, no, never mind.
x, y, z, right? And then I need to make a displacement vector from one of my points to that. Which one do you want to use?
1, 0, 1, 0.
Yeah, 1, 0, 0.
Okay, so there's your displacement vector, right? That thing has coordinates
X minus 1.
x minus 1, y, z. And what do I know about that and that put together?
The 1, 1, 1 are the coefficients of the x minus 1, y, and z.
Oh, perfect, yeah. So I know that if I dot this with that, I get 0 out, right? Because that thing sticks straight out of this plane, right? So I get 1, 1, 1 dotted with x minus 1, y, z. I'm standing right in front of this, sorry. Equals, yeah, go.
Why is it that we can change the -1, -1, -1 to positives?
Good. So this black vector stuck this way, right? That's perpendicular to the plane. Do I care if it sticks straight that way? Is it still perpendicular to the plane? Yeah.
Okay.
So actually any constant multiple of this thing will work. And that's because you're setting this dot product equal to 0, right? So you can multiply both sides of the equation by whatever. Cool?
We just picked one of the 3 points for our plugin.
Yeah, and it won't matter at all. So if you pick different points to make different blue displacement vectors in the beginning, it won't change anything. If you pick a different point to base your green vector at, it won't change anything. If you flip that cross product around, it won't change anything. There's a lot of freedom here. In the end, what do you get?
X plus y plus z equals 1.
Perfect. X plus y plus z is 1. Then you got that by saying x minus 1 plus y plus z is 0, and then adding 1 to both sides. Cool? Check. Questions? So, back through. What did we do? What was the moral of this? Like, what was your procedure?
Break it up.
Okay, so I would say the procedure was we drew our 3 points, we made 2 displacement vectors, we got a normal vector, then we made another displacement vector, set the dot product equal to 0, and we were done. Cool.